Inter-process communication. Processes frequently need to communicate with other processes. As we have already given, suppose if we want to insert an image into a Word file, the Word file has to just read in the name of the file where your image is stored. Then it opens that particular file, reads in the contents of the file, and insert all the content one by one into itself. So for that, the Word file or the process that is um, running the Word file has to go and talk to another process which can read the contents of the image file. So most of the times when multiple processes are running, usually one process keeps talking to the other process in order to do the needful. Suppose you need to insert image or clip into a Word file, then the Word process has to open another file called image.png. Thus, it creates a new child process that reads contents of the image.png and writes them to the Word file. For this, the Word file needs to communicate with the image process to request it to send data. This is pretty common in most operating systems. When many processes are running concurrently, each process keeps talking to the other process. Another example is whenever we start an operating system or whenever you boot your computer, whether it is Windows or Linux, first the boot process starts. Once the operating system is completely booted, we need to open our application. The application could be Word, the application could be Excel, the application could be maybe your WhatsApp. The first thing that you do when you come to office in the morning is check your WhatsApp. But for that we need to boot our system and then we need to open the WhatsApp application and then go to whichever message you would like to read. Similarly in Linux, first you need to boot the operating system and then if you need to work with commands like process, ls, etc. First you need to boot your Linux. Then open the command shell. Command shell happens to be a second process after the booting process. Then get into the shell pipeline and type down whatever command you want to type. Once the command is typed, the command needs to be compiled first. So it goes to the compiler, checks the meaning of the command. If suppose the command is wrongly spelled or the format is wrong, it immediately gives an error to me saying that I need to write down proper format or properly spell it. Once I write it in a proper format, it runs that particular command and accordingly it gives me the output. So therefore there are concurrently multiple processes which are running and they're also talking to each other. Why? In a Linux bash shell, when I typed a command, it opened the compiler process. In the compiler, there's a dictionary of words. It goes, checks the words one by one, tries to match a word which I typed. Now suppose if it didn't find any word of this spelling, it immediately says that the compiler defines to the process that if the word is not found, you have to immediately come down and give some error. What error it gives, that is also defined in the compiler. So it is talking to the compiler process and whatever the compiler gave as an output, that is written on the standard out, that is the monitor. So thus there is a need for communication between processes. But when processes are communicating with each other, as far as if one process is not disturbing the other process, we don't have any other problem. In case of Word, reading the contents of an image file and simply inserting them to the Word file, I don't have any problem. But if the Word process, while it is reading, if it is rubbing off some of the contents of the image file, then I really have a problem because next time when I need to insert the image, the file remains disturbed. So there are some issues when processes start communicating to each other. So one needs to understand how one file is able to read the contents of another file and get it and put it in this particular file. How is it appending? How is it copying? Or how it is passing data from one process to another, or passing information from one process to another. Remember, it is a machine which is passing information from one place to another place. When the machine is passing information from one place to another place, then it should have some data structure, a variable, an array or something which just copies things into it, gets it, and again copies things from the variable back to your file. Now, what data structure it is going to use, we will look at it later. That is the first thing. How processes pass one information to the other, what kind of technique they use. The second one is, if two processes are accessing the same data, are they not disturbing each other? Are they not getting in each other's way? We take the example of debit card and UPI. If two people are trying to do a transaction from the same bank account using a UPI and debit card, and as we gave in an airline reservation system, they're contending to book the last seat. Two people trying to contend to book the last seat, and they all send their request within seconds difference. And if suppose the system gets confused, then it might book seat to both of them, or it might cancel seat to both of them, which is a very wrong thing that can happen with a reservation system. In a railway reservation, no two people will be allocated the same seat at any time. In bank system, even if two people, if my daughter is doing a transaction in Bangalore and I'm doing a transaction in Mumbai at the same time, and I try to buy something for 25,000 and she tries to buy something for 10,000, and my bank account unfortunately has only 25,000 rupees, and requests come at the same time, if both transactions get accepted, I get into a trouble. The bank gets into a trouble, because once we just buy something, we don't like to return. So, but bank has some ways, even if it is microseconds difference between two transactions, it has some ways to stop it. So we'll find out how we can prevent two processes from getting each other's way. Then the third one is concerns in proper sequencing. Now, when two processes are contending for the same data, or when two processors are trying to ask for CPU's time, how are we going to sequence the processes? Who should do things first and who should do things later? Now, sequencing is very, very important in the world of CPU. And today we are talking about multitasking, multi-programming, and multi-user systems. In these multitasking, multi-user, and multi-program systems, sequencing is very, very important. Agar if you are not going to look at more prioritized processes and give sequencing in a inappropriate manner, लड़ाई हो जाएगी लोगों के बीच में. लोग बोलेंगे मैम मैंने फर्स्ट असाइनमेंट दिया और आपने दूसरों का करेक्शन कर दिया. Sequencing happens to be very, very important. It's also important that two of the three issues apply equally well to threads. As far as if this is the issues regarding processes which are contending, but these could be the issues for threads which are contending also, because for threads it's going to be more easier compared to processes, because threads don't share their memory. Both the threads work from the same process control block. They don't have any separate process control blocks. So therefore, searching for any data, whether a modification occurred or passing of the information from one thread to another, should be very easy, because both of them, their memory locations are a shared memory location in the same process control block. So the address space is going to be the same. Now, keeping out of each other's hair and proper sequencing, ये मामला और ये मसला जो है threads में भी होगा. Because whether it is threads or processes, we know that एक दूसरे को अपना टांग नहीं खींचना है, जैसे क्यू में खड़ा होना जरूरी है. बिकॉज दोनों एक ही समय में अगर टांग खींचेंगे, सिस्टम जो है ओवरवेल्म हो जाएगी और गलती जरूर करेगी. Now, the next important definition is race condition. So, what is race condition? Now, when two processes are contending for the same data, ऐसा तो नहीं कि मैं सोचती हूँ कि मैं प्रोसेस बी के लिए त्याग करती हूँ और लेट इट फिनिश करके मैं उसके लिए रुकता हूँ, और प्रोसेस बी जो है वो कभी भी अपना काम खत्म नहीं करेगी. और वो करता ही रहेगी। और ऐसा तो होगा कि मैं ज़िंदगी भर प्रोसेस बी के लिए वेट करती रहूँगी और वो कभी ख़त्म नहीं करेगी, तो मेरा काम और मेरा चांस कभी नहीं आएगा। Such conditions where the process keeps on waiting and it is never attended is called as a race condition. So in some operating systems, processes that are working together may share some common storage. Usually, when I'm talking about the bank transaction, one is using UPI, the other one is using the debit card. We are talking about the common storage. Why? Both of them are trying to request from the same bank, same account. So now, if UPI 1 doesn't finish its transaction forever, then I don't think debit card will be able to ever access that bank account. And it keeps on waiting. दिन भर wait किया, बैंक से respond नहीं आया. Hopefully it must be an emergency transaction like booking a railway ticket for an important meeting. And it keeps waiting, tried it 10 times, 20 times, and never it got an answer. And it keeps waiting. That is called a race condition. Unfortunately, we were provided debit card and UPI इसलिए ताकि we are more facilitated, so that whenever we want, we can do it with whatever tool that we have. But unfortunately, if most of them don't work, I don't think we like it. So therefore, even in processes like printing a page, if one of the process is never able to print one page, it is called as a race condition. Because why is it not printing? Because it was thinking that the printer which was printing one page, let it finish it off and come back to me. But I was trying to be a gentleman, but the printer never came back to me. When the printer never came back to me, that means I'm always waiting. मुझे जवाब कभी नहीं मिला. That's called as a race condition. So for example, we'll take one particular example here. When a process wants to print a file, it enters the file name in a special spooler directory. We all have this in our operating system. When I try to connect a printer to my laptop, usually printer जो भी files print करना है वो एक queue में लगाती है. Usually that queue is called a spooler directory. The spooler directory सारे print jobs को एक queue में लगाती है. जो फर्स्ट आता है पहले उसको प्रिंट करती है, जो सेकंड लगाया दूसरा उसको प्रिंट करती है. सो इट हैज गॉट अ क्यू. But the queue is limitless? Nah, it is not limitless. It has got a finite size. Let us say it has got 10 slots. So imagine that our spooler directory has large number of slots. Suppose let us say large means not unlimited. It is a certain number of slots. Let us say n slots. There are two shared variables. One shared variable is called out. Out will tell me which page should be printed first, which is the next page that needs to be printed. In will tell me which is the next slot which is empty. What are we writing in the slots? We are writing the print job, that is the file name and the page that I need to be printed. So suppose in the examination branch, I said we have two printers, we have 6 people who want to print their question papers. So the first person will send his print request saying that I want to print 10 question papers. The second person will send, I want to print 20 question papers. Where are these question papers saved? In some file. So what the queue is going to write down? The queue is going to write down name of the file and the page number which needs to be printed and how many copies it needs to print. So my in directory will show me, suppose only 3 people gave the job. Now my queue size is around 10. That means 3 slots have been filled with file names and the remaining 7 slots, now they are empty. So what is the next slot that I can write down the file name if a 4th person is asking? The 4th slot. So at a certain instance, suppose slots 0 to 3 are empty. That means they are already printed. But 4, 5, 6, they have some file names which need to be printed. So more or less simultaneously, process A and B decide that we need to send some print jobs into the spooler directory. So what process A comes down, it checks this spooler directory. It says that It doesn't know that 0 to 3 are empty. What it looks is it has got only two variables, in variable and out variable. In out variable is read by the printer. In variable is read by the processes. It reads the in variable. The in variable says that the next slot where I need to write down my file name is 7. In this meantime, process A becomes busy with something. It says that let me go attend some phone and come back. अरे बाबा मैंने देख लिया कि 7 स्लॉट एम्प्टी है. होता है ना कभी कभी हम लोग रेलवे में या मिल्क क्यू में जाते हैं, देखा कि एक जन ही है, दो जन ही है करके देखा, सोचा कि एक ही जन है ना, बहुत दूध है, लेट मी गो हैव अ कप ऑफ टी एंड कम बैक. बाय द टाइम आई गो हैव माय कप ऑफ टी एंड कम बैक, वहां पे 2 जन ने 100 जन आ जाएंगे. So I will never get milk, nor I will never get railway tickets. सारे खत्म हो जाएंगे. So that's why you should never. I always think that I put the alarm at 4 o'clock. I get up at 3 o'clock. I see it's just 3 o'clock. Let me sleep again and get up at 4 o'clock. But next time when I get up, it will not be 4 o'clock, but instead it will be 6 o'clock. Then I cannot read anything. I have to run and come to the office. So it was like this. So process A comes down, it reads the invariable and sees that the next slot that needs to be filled is slot number 7. But in this meantime, since it has to do so many things, it goes and attends some other thing. But it just remembers that, let me just remember that slot 7 is the one that needs to be filled. वो अपनी डायरी में next slot to be filled is 7 करके लिख के कहीं चली जाएगी. In this meantime, process B comes down because process A ने 7th slot में file name कुछ नहीं लिखा and it didn't update the in variable. B comes down and sees the slot. When it comes down and sees the in variable, it again reads that the next slot to be filled is 7. So B comes down, it writes down its file name to be printed in the slot 7. And it says that the printer will be printing my job, and it goes off. Now, in this meantime, process A comes down and checks the slots. It doesn't even check the slot 7. It checks its diary. The diary may slot number 7 is written. So therefore it just remembers that, oh, I need to write down my file name in slot number 7, comes down and it overwrites the slot number 7. वहाँ उसका फाइल नेम लिख देती है. उसका फाइल नेम लिख के वापस चली जाती है. अब प्रिंट स्पूलर क्या करती है, 1 by 1 एक एक स्लॉट चेक करती है और 7 स्लॉट पे आती है और प्रोसेस ए का जॉब प्रिंट कर देती है. बेचारा प्रोसेस भी सोचते मैंने प्रिंटर को अपना जॉब दे दिया, वो अपना काम कर देगा करके वो वेट करती रहती है. बट वो होगा ना, बिकॉज 7 had the process A's file name. So it keeps on waiting and it will never get its job done. So conditions like this where you have to wait for infinite time is called race condition. So usually we have to find out programming ways where we should avoid race conditions. All these facilities are created so that every process is offered some service. If it stops offering the service, then I say it is not a right system.